my name is Luke Bandy. I am a junior data scientist at the Pensions Regulator, and you might already be going, this doesn't seem very pensions related. So this is actually a project that I built as part of the university course that I'm currently on. I'm currently doing a degree apprenticeship in data science. So this is just some coursework that I did a few months ago. So yeah, just to outline it, going to go over what the data is, then how I scrape the data out and how I stored it, then how I export the data with some basic visuals, and then how I put those visuals into a dashboard. So to introduce the data, each month, the New York City Taxi and Limousine Commission releases records of trips made. So the details of these trips include when the passengers got picked up, when they got dropped off, where they got picked up and where they got dropped off, and other details like how many passengers are in the vehicle. They also release some metadata about like the zones within New York. So the pickup and drop-off locations aren't like an accurate, longitude and latitude. They're just, they got picked up in this area of New York and dropped off in this other area. And we get some nice data dictionaries and stuff just to explain the data a bit more. If I flick over to their website, you can see how the data kind of looks when they're not intending for anyone to be bulk downloading every month's worth of data. And obviously, I don't want to have to click on every 4 different file downloads for each month. And I wanted the data back till 2015. So that's a lot of buttons to click on. So, and I found this data set originally on Kaggle, but similarly, that was a really small subset of the data. I really wanted, a nice big picture of what's been going on. So in terms of scraping the data, all the files are Apache Parquet format, which is like a nice compressed tabular format. It's a much smaller file size than a CSV file, but obviously because it's compressed, it requires decompression, so it can be a little bit slow to read. And those zones that I mentioned, the metadata about them is stored in a shape file, but we'll come on to them a little bit later. So essentially, the utils library that automatically gets loaded when you start R includes a function called download.file, which is great. So essentially, I'll create a list of all the different CloudFront URLs that I want to download these files from. And just as we looked at a minute ago, use mutate to quickly download all of these files, although I don't actually want it that quick. I only want it to do one at a time because otherwise Netflix won't work in the living room if I try and download all of these files at once. There's some issues where some files aren't available. So certain months, certain different types of taxi, type of vehicle won't be available. So what we can use is PERS safely function, and we can wrap the download.file function into this possibly, sorry, I've got that a bit wrong. It's not per safely, it's per possibly. And you can see here where a wrap download.file into possibly. Download.file normally returns a 0 when it's successfully downloaded the file. But I just say, if you fail to download the file, just say -1 instead. And that means we get this nice data frame showing if a file is successfully downloaded or if it's unsuccessfully downloaded. So you can see here that they haven't released the May and June data yet for these vehicle types. So it's unsuccessfully downloaded, but that's fine. We can rerun it next month and hopefully they've released that data by then. So I also wanted to scrape out the routes between each of the zones. And for this, I wanted to use the Google Maps API. So I used a library called RGDAL. I'm not sure how you're supposed to pronounce that. And we can use that to read in this shape file that they provide. And then I needed to work out the centroid of each of those zones. And there's this other library called rgeos. So we can systematically ask it to calculate the centroid of each of the zones within New York. So once we've got each of those centroids, I've got an example of just asking Google Maps for directions between two hard-coded coordinates here. But yeah, using the Maps API library, we can easily ask the Google Maps API for the directions between each of these zones. And this will be really cool when we visualize it. Right now, it might be a bit meaningless. But don't do as I've done, because Google got a little bit annoyed at me for doing this. But luckily, they got annoyed at me after I finished. Turns out you're not allowed to scrape Google Maps API for data. Good to know, though. So as I mentioned, we have all these Parquet files, but they're really slow to load. I think it takes about half an hour to load all of them. And frankly, we don't need all the data that's there. So after reading in each of the Parquet files, we just take a 0.01% sample of all of the trips, and then do some cleaning, drop some unused columns, and then spit them out into an RDS file, which allows us to load it really quickly. This gets about 29 gigs worth of data down to 50 megabytes, which is great because later I'm going to publish it online and I don't have, a huge database to store it in, or a huge online cloud folder to store it in. So I want the file to be nice and small. And that means that later when we go onto the shiny stuff, it'll load up really quickly as well. So we've got some code here where, so if I tried to load all of the Parquet files, combine them, and then take a 0.01% sample, my computer would run out of memory. It can't load all of this data at once. So what we do is we load one file, take the sample of it, stick it onto the collection, and then go through all the files rather than taking the sample at the end. And you can see I've got this nice little function that reads in the file on line 12 and then takes a sample. Sorry, no live code demos here, but the code is on GitHub later if anyone wants to take a closer look. And you can see here we're just finding all of the files that we've downloaded in that previous script with list.files, and then using pers mapdf function to return this combined list of, all these combined data frames from the Parquet files. So now that we've got the data, I've made a R Markdown notebook. So for those that haven't used R Markdowns notebooks before, it makes it really easy to flick between all the visuals rather than relying on the plots pane in RStudio. It's also great because you can integrate other languages, including Python and LaTeX. So for an example, in a previous piece of coursework that I've done at uni, I've generated some visuals using some R code and then made some scientific notation using LaTeX, which is lovely. It's nice to be able to render it all into one. Then we can easily export it into different formats such as HTML or PDF. So luckily my lecturers can receive this, the output of this in a PDF. And similarly, my exploration for the taxi trip data was spat out as a HTML, and that's available on, I can't remember what it is. It's publicly hosted so that anyone can access it through a URL, and there'll be a link to that later as well. So I've gone and made some non-geographical visuals with ggplot2. So these are an example of a few of the, the kind of more common visuals, but the one that I think everyone finds the most interesting really is this one, which shows the number of taxi trips made by vehicle type each month. Also, you can see it's pretty consistent, and then all of a sudden COVID-19 happens and it plummets. But you can see that it's slowly been increasing, and in a minute I'll actually show an updated version where you can see it's increased even further. And also you can see it's interesting that vehicle types kind of magically changed at the start of 2019 from this for hire vehicle to high volume for hire vehicle. And I believe that's around legislation of Uber, the way that Uber trips get categorized. So that must have changed at the start of 2019. Similarly, we can look at this one and see that, you know, throughout a typical day, the amount of trips that happen are pretty consistent, but at nighttime it drops down. There's also quite a bit of a spike around 4 or 5-ish. I guess this is when people finish work and they want to get a taxi home. And you can see a little bit of a spike at, you know, early in the morning as well. Must be people getting to work. So all of these, the y-axis, you know, you remember we sampled all the data by 0.01%. The things like the y-axis here have been multiplied by 10,000 to kind of reverse the sampling that we've done. That means that these plots can be generated much more quickly. So they're not quite as accurate as if we use the whole data set, but, you know, to the blind eye, to the naked eye, you can't really see the difference. It's much easier to prototype the visuals that way. Otherwise, you'd be sat there for hours waiting for these visuals to render. So moving on, the more interesting visuals are really these geographical ones. So I've created these interactive maps using Leaflet. The first thing I did was plot the shapes of each of the zones that we downloaded from the website earlier, and then change the shade of those zones based on the popularity. So you can see here that the darker zones are more popular, and this big one down here, I believe, is an airport. And so you can imagine there's lots of people getting picked up and dropped off, and then people tend to seem to get ferried over to this part of New York. I'm not very clued up on the workings of New York, but I imagine this is, you know, the busier area of New York, right? Interestingly, this area here is also an airport, but clearly a much less popular airport. So next, I decided to plot polylines of each route, and this is the data that we got back from the Google Maps API. And similarly with the shade of the zones, I gave each line a different opacity based on how popular it is. So the more popular, the darker. And this means that if we have overlapping lines, the opacity will kind of, you know, work together to form a darker line. So interestingly, you know, if you look at the bridge on the map, all the routes are getting forced over the same route, which means that that bridge becomes much darker. And similarly, you know, you can see that this area here of New York is much busier than the surrounding areas. And of course, there's these couple of little routes coming from this distant airport, which is quite interesting to see as well. So another thing I tried was adding tooltips to the zones. So when you click on the zone, it gives you some information about the zone. So you can see here, I've clicked on Crown Heights North, and it tells me that is Crown Heights North, and it gives me the rank of how popular it is in terms of pickups and drop-offs. And these are all interactive. Obviously, these are screenshots, but in a second, I'll give a little interactive demo. So next, I wanted to build a dashboard to put all these visuals into. The R Markdown notebook output's great, but you know, with a dashboard, we can do things like add filters, so that the user can, in this case, adjust the range of dates of the trips that they want to look at. They can filter the vehicle types. And you can also adjust the sample size further from 1 in 10,000. So this is kind of interesting because you can see how the visuals change. In theory, they shouldn't change much as you sample further, but it does also help with performance because it's having to do with a lot less trips at once. And you can see I've also added some key metrics at the top. I'll actually just go over to the dashboard. That would make way more sense, wouldn't it? So one of the reasons why we sampled the data, I sampled the data much further down to that 1 in 10,000, is so that Shiny Apps would let me upload the data set. They get a bit funny when things go over about 50 meg. So give it a second to load. So yeah, we can see at the top here that we've got these kind of key metrics. probably most interestingly, the average cost of a trip and how long the trip on average lasts. We can then go and interact with that leaflet map that I just showed off. And yeah, if I click on, click on a zone, it'll give me the awesome details about it. So next thing I was going to show off, sorry, if I scroll down, you can see some other visuals as well, like the ones that we saw earlier. So you might be asking, Luke, can't I just do this in Power BI or something quite easily? And it'll, have the fancy cross filtering and things. Unfortunately, the map visuals I've had a go at doing in Power BI. They don't work. Leaflet for this works really well, and is used quite a lot in various industries. I've noticed delivery companies using it to show where your delivery driver is and things like that. It's very commonly used. But a lot of Shiny apps are missing that cross filtering that Power BI offers between different visuals. But turns out that you can add it, and I've got some examples of how I've done it here. So for example, if you click on a zone in a map, it will filter other visuals for trips that started or finished in that location. So in the top right, you can see a bit of a code snippet explaining how I've done that. So I've got this function that renders a leaflet map. I say when the code gets run, it says by default nothing selected. But then in the event that the map gets clicked with, a zone on the map gets clicked, it then goes and says, change the selection variable to be the zone ID that just got clicked. And similarly, if you click the background of the map, it resets that to null, so that our reactive functions can adjust based on what's being clicked. And similarly, there's a table that does this. You can select a specific route in a table that I'll show in a second. And you can see here I'm rendering out the table, and I've got this reactive function that can look to see which rows have been selected. You have to write some code to handle if no rows have been selected, but yeah, that's possible. So it's a bit more work than Power BI automatically going, let's do cross filtering, but it is possible. So I'll go and give a quick demo of that. So obviously I just clicked on one area of the Gramercy area in New York. So things like our heat map have now filtered just to show the most popular routes that feature Gramercy, either as a pickup or drop-off location. So you can see that trips from Gramercy to Murray Hill are really popular. Then if we go to the table, we can find specific routes featuring Gramercy. And so this line graph down here shows the average speed over time of routes featuring Gramercy, and is designed to show if there was like a month that was slow routes, so maybe due to construction work or something on a road that people would use to get between those two areas. But I can go and select this specific route that I'm interested in, and the line graph will filter. It should filter, but I think there's not enough data about it. Let's try a couple more. Never do demos live, folks. It's never a good idea. Not sure why it's not working, but it does work, I promise. You can go and have a play around later, and maybe it will work for you. Cool, so I've got some resources here. I'm sure we can send out the slides or whatever if anyone's interested, including my GitHub repo and a link to the dashboard.